Alright guys, this is my Astro-Physics Mach2 mount, and I want to do a dual scope setup with my 130 GTX and my 92mm Stowaway. I'm going to use the same procedure for balancing that I did in my video when I did the dual scope setup on the 1600 mount with the 175 f8 and then the 130 GTX. Now the Mach2 has dedicated internal cabling, and so that being the case, you can't just take this deck cap here and just turn it around and around and around, because obviously with the internal cabling something's going to break. So there are hard stops in here to prevent that from happening. So when I got the mount, I noticed that it had an arrow at the top. Well, I hadn't looked at the directions, but I knew right away that with internal cabling that it had to have some direction to it, and it must have had a dead stop or hard stop. So I just naturally put the plate on, the saddle plate, like you see right here, because when I set up any of my mounts, I like the locking knobs to the east side of the mount. That's just me, so that I know now that no matter how this is orientated, this will be the top of the mount here. Now I'll show you as I rotate this. First I'll rotate it counterclockwise, and there you see it hit the dead stop. Rotate it clockwise, and there it hit the dead stop. So there's only one thing that I've got to do in this setup differently than I did with the 175 and 130 dual scope setup. Now I had two options. One was to take the saddle plate off and rotate it 90 degrees, keeping the arrow up on the deck cap, either way 90 degrees. If I was going to do it, I'd have the locking knobs facing down, or leave this permanently like I want to and have an interface between this saddle plate and the side-by-side setup. And so that is what I elected to do, is forego taking this off, leaving this on here, and just putting something in between this and the side-by-side plate, and then that could easily be taken off. So now here's the piece that I came up with that's going to go in between the that's going to get me shifted around. And so basically what you have is another saddle plate. It's the DOVE DV10. It's the same unit that you saw on the Mach2. And so what we have is, this is the way it's going to sit on there. You're going to have this dovetail plate that will go into the saddle on the Mach2, and this now rotates me the 90 degrees that I want. Now this piece does add 5 pounds 14 ounces to the weight of the system. No big deal. And so this works really well by doing this. One of the things I had to consider was getting a dovetail. Now I looked at Astro-Physics and different other companies, and the problem with them was that the underside was all cut out to save weight in various areas. It kept the rigidity, but they wanted, you know, to save weight. And the issue with me was going to be, well, how are these going to hold up? Or how are these going to line up to the cavities in the bottom of the dovetail. And because this is critical here, and you can't have anything, you know, I was going to drill and tap. So I didn't want to fool around. There was no schematic showing, or drawing showing, you know, the locations of those. And then I remembered a buddy of mine, Tom, several years ago, before I was going to do my dual scope setup on the 175 and 130, he gave me, this is from Las Mandy. Because he said, here, take this. He says, I'm not using it. You could use this. And then it also came with, as you see here, you see these holes here, these two here and the two here. That's where the G11 type saddle was. So it had two G11 type saddles sitting like this. And so when I remembered this, I took it back out of storage, and lo and behold, this is solid. Perfect. Because now, no matter what I do, I know I'm getting into solid stock. And so that's what I did. I laid this all out like I do everything, all by hand. Located them and drilled and tapped for 1/4-20s. And then to that, I added some stops. These are just some nylon 1/4-inch diameter internal holes. And this is in case I need to attach my, I have a system in which I, to keep things from moving, to tie it down while I'm setting up. But these both act as stops on the saddle plate, so if it got loose a little bit, it would slide down, hit this, and not go any further. Alright, let's see how that's going to work. I always like to snug them up. Alright, so I know you're asking yourself, what's going on with this middle knob? It's missing. Well, as you can tell, the diameter of this knob was big enough that it wouldn't work here. Now, one of my thoughts was just leave it off, and that's what I was going to do. Well, I got to thinking, these are 1/4-20s. Okay, those are 1/4-20s. So what I did is I took a coupling nut. I always have a lot of different things in stock because I'm always working on something. And so I have these, and these are 1/4-20. So what I ended up doing was taking this coupling nut, then I put a short, well, there goes that, and then I put a short socket head cap screw in there, stainless steel, I think it was just 1/2 inch, and Loctited it in there, thus creating the thing to push against here, and now I could have all three of them working. And as you can see, that length works out nice because it brings it to the same length of these other ones, and it brings it out further, so now I can use this to tighten it up. And by the way, I made this thing up. Well, it's basically, the handle is from Snap-on. It's a TM40 ASA, and I have the older version of this. God, I've had it for years and years. And it's more rounded, well, it's more squared off, where this has these little dimples in it. What I find, this really works nice. My initial thing when I made this up was just giving these just a little bit of a snug. Because I've got arthritis, and sometimes it's really hard to, here with the palm here with my thumb in this area. So what I'll normally do is just snug that like that, and then this tool allows me just a little bit extra, and this handle is nice because it doesn't allow you to get a whole lot of torque on it, and you just get that feel, just a little bit extra. And then this is a long 3/16. Let's see, is that yeah, 3/16 ball end Allen wrench from Cobalt. I actually have a set, but I bought another set so I could use this dedicated just for the this purpose. And here we have the side-by-side arrangement, and it consists of two DOVE DV10s, and then this is the 13-inch side-by-side Astro-Physics number SBD13SS. Now, as you can see, what I was talking about earlier, what Astro-Physics and everybody's doing now with their dovetail plates is they're hollowed out, and so that was the issue I had with that other piece. So I was very happy that I had the solid dovetail. And this particular arrangement right here, as you see, weighs in at 7 pounds 8.7 ounces. And you can see that I've added the stops on this also. Now, if you saw my video that I did with the 175 and 130 side by side, I also had to with this particular saddle, it doesn't, there's a gap that you can see there, and so since this isn't doweled, it doesn't have anything locating it per se other than just these bolts. I had to put these basically they're just feeler gauges. You can get cheaper feeler gauges, so I bought two sets because you need one for each side. And you know, I believe it was a 4 thousandths, 6 thousandths, 23 thousandths, 24 thousandths, and a 25 thousandths that I put together. And you want to be careful that they don't get too thick. You don't want them too thick, because when you do this, you just want it to where everything gets flat down here. You want to make sure this stays flat. You just want that wedged enough to keep this edge parallel to the edge that's cut out on the side-by-side plate. Alright guys, let's take a look at this. And I may have forgot to mention that I put this piece of hose on here. I just so that way when you're working around the painted parts of the mount, like say in here or whatever, you don't damage anything, especially when you're using this with the your clutch knobs down here when you're tightening it up. So, but that's why that's on there. And what I did is I just cut it to the length I wanted, put a little bit of hot glue on one side, and then pushed it on just to kind of hold it from falling off. So let me show you something I'm fooling around with here. I'm always looking at different ways of doing things. In some of my other videos, you've seen that I've used chain and hooks and stuff when setting something up to hold the mount in a certain position, especially for something like this. So what I'm doing here, this is an item by Night Eyes, and that's that hook that I put on that plate there. And so what I'm doing is I'm hooking this on that eye, and just wrapping it down on this hook that I already had on my ATS 12-inch pier, portable pier. But you can hook that to anything. I can hook it to the handle, hook it around this leg, and this is paracord. And here I'm doing the same thing on the counterweight shaft end, and I made this up, and basically I put a 30-pound weight on here, and I can always add more if I need to, but I've got that on there. And then this I'm going to tie down to the leg and do the same thing. Now those are from Night Eyes. They're aluminum cord tighteners. It says 300-pound brake strength. Night Eyes makes some really interesting stuff. And what's really interesting is you can buy it like this with the orange paracord, and it's cheaper than buying just one of these separate. Now they show a different strength rating on these without the cord, but they're the same unit, the exact same numbers, everything. So I don't know if they're basing that on the cord. So it was just cheaper, more beneficial to buy it with the cord. And then obviously you're going to need two of them, because you only get one of these with this, but then you just pull one off the other cord and you're still cheaper off the other pack. You're still cheaper than buying just this by itself. So this is just something I'm experimenting with to see how well this works. Now here's what I did to this is the Astro-Physics counterweight safety stop. So what I did is I used 5/16 stainless steel eye bolt, drilled down into the center, put a this is all stainless, put a 5/16 nut on here, jammed it on here so it's you know, tighten it real tight up against where the threads stop. Put a washer on, and then on the back side put a washer that fit perfect. If you drill that really in the center, that 5/16 washer, you'll see, if you can see it in there, there we go, facing to the sun, fits in there perfect, the diameter of that. So as long as you get that in the center, you're good to go. And then I used a 5/16 nylock nut and just tightened it until it got the right feel, where it's not too loose, wobbly, but just turns. And then I had to grind some off, so that way when it got screwed into the counterweight shaft end, the length wasn't hitting. So I got one a little longer than I needed, because I want to make damn sure I had enough, and then whatever I needed I just ground off. Pretty simple. So here you can see I just put it in between one of the braces on the tripod, hooked it up here, and then the beauty of this is you just pull down on it and it tightens up. So now what I've done is kind of wedge this so that when I put things on it with the axis loose, I can still tighten them if I want, but what I don't want it something to do is to go one way or another. It keeps this from moving quickly and doing any damage, especially because you got the dead stops. That's one of the reasons for this, is because you wouldn't want it to turn in such a fashion to damage the dead stop and break it. Alright, so this is tricky, guys. So as I did before, I put the big scope on first, and I want to get it leveled. And then I'll take a dimension, I'll measure it, make note of where it is. I will take that off, flip that arrangement that you see there 180 degrees, and then put the 92 millimeter up on this one and do the very same thing. Make note of where that's at. Then put them both on in the proper spacing that would be on the dovetail plate. So what I would do is take a dimension probably on the front side. What I was doing on the other ones, I'm on the back side at the moment. Just take a measurement from the end to here. Make note of that. So once I get everything tweaked, when I want to set it up again, it's very simple. But you'll see how this is balanced. But just by bringing in the draw tube, see how that changes? But I found with that other big setup that I had, see how that changed? But with the big setup that I had with the 175 and the 130, that little change, once you get it tweaked and you throw eyepieces in or something, the mount doesn't even know it's there. So I found that not to be a major issue. So here's the 92 setup, and it's somewhat pretty well balanced, just like this here. And I've got the draw tube all the way out. And as I said earlier, that little bit of imbalance, when you add an eyepiece or something like that, really doesn't hurt a thing. And this is they're heavy mounts. It's not going to be that bad, and I can always tweak it a little bit forward or back once it's in here like this. This is just to get me going, and I'll take a dimension on here now, and then I'll go ahead and put the 130 on. Alright guys, so now you see both scopes are set up, and they're fairly stable that way. And again, you can tweak it a little bit. This gets me going. I'd rather have it a hair heavy on the lens end. That way when I put eyepieces and stuff here, it all balances out. Alright guys, so this is trial and error. I've got it all set up, and I've got this moved in. Once you get the initial adjustments, the 130 needs to get closer to the center line of the saddle. I'm already up against the dead stop, so now what I'm going to do is take the dead stop off and slide it in a little bit more. Like I said, this is the first time I'm doing any of this, is right now, just to show you guys how I'm doing this. And hopefully the audio, I put a piece of masking tape on top of my the speaker. I'm just using a $400 camera. I'm not using anything special. It's very windy today coming out of the north. It's very brisk. So anyways, so that's what we got. I'm going to pull that off, move that in a little bit further, and we should be adjusted pretty good. Alright, there you are. Everything is set up perfectly. It's nicely balanced, as you see in this configuration. Those are two 30-pound counterweights. I've taken all my dimensions so I can put this together next time very quickly, just as I do with my 175 and 130. Once you know what the setup should be, I just take measurements, write them down. I also take pictures of the various locations, go into Photoshop, and then I'll put that into my phone, so that way when I set it up, I just look at that and it documents it. Okay, so this is my neighbor Mike, and he's going to show us how well balanced the scope is. Okay, thank you, Mike. I appreciate that.